So this week I continued on with trying to figure out why Pure Pursuit doesn't work, why it doesn't work on my physical vehicle, which is this vehicle right here, and it's got the GPS RTK GPS in the back, and on the front it's got the antenna for the static heading for the GPS, and then otherwise I just take it out in the yard, load the software, and tell it to drive around a path. So what I was doing was I was using that standard Larics Pure Pursuit. So if you go to ROS and say, show me Pure Pursuit, it goes to the ROS wiki and pulls up one, says, here's one from Larics. Somebody called Larics. I don't know if that's a company or a name or what that is. But anyway, you load that up and you can then run that. And I do notice that it says everything is 6 years old on that. So you think, oh, it's nice and stable and everything works. But I go run it and it doesn't seem to work. But now if I run it on the simulator, it seems to work on the simulator. So Al and I have been discussing why is that? Is it because the GPS update is too slow, or is it because the steering is too slow on the vehicle? Or if you try to drive faster, if you try to drive too fast, it makes your steering appear slow. So it might be a combination of any of those three things. And let's see. Okay, let's see. Where was I? So I can also run it on the simulator, and the one on the simulator seems to work a lot better. In fact, it looks quite acceptable. And the main differences there are I have a faster GPS update rate on my vehicle, this physical vehicle right here. I run that at a 5 hertz update rate for various reasons. And then on the simulator, it's set to 10 hertz. And on the simulator, the steering isn't hampered by how fast your vehicle can physically steer, which mine is, because it's got a giant RC servo on it, and that controls how fast the steering can run. And then when I was doing the physical testing, I have it patched where I can say just use the forward speed comes from my joystick. So once I say enable Pure Pursuit and publish a path, then once I do that, you'll see the wheels will turn and they'll turn in the direction it's got to go. And then if I push up on the joystick, I can control the speed of the vehicle. And that way, number one, it won't get away from me. And number two, if I decide to run it fast or slow, I've got the option of doing that. So what I'll do is I'll show a couple of videos here. And I also posted those videos out to our channel, and I'll put the link in the chat here when I'm done, so you can go look at those. So if I come over here to this other computer and say, let's see, start sharing, I am sharing. So if I say, go to here. Well, no, apparently I'm not sharing because it's not showing up. So let me come down here and say, start sharing. It says select entire screen and say, go. Oh, it's not doing that because I don't have the video turned on. Okay, so I'll say do this. Come on. Why is that not working? It's showing up on the other computer. Do I have something saying it's unhappy? So it could be this is not going to work because we just had it running, and now it says
I'm getting a message that says you're viewing Jeff's screen, but it's blank or it's dark.
that's what mine's telling me too. And why is it? Let me turn my video on just for the heck of it. So it shows up at the top as my little box. Well, let me say stop. Let me just go through that sequence again. I'll say stop sharing. And let me turn this on just because. Okay, so I just spent 5 minutes in the background getting this to display, and now it's coming up. So what we're seeing here, this is a screen recording from RVIZ. So what I did, I ran both my physical vehicle and created a bag file, and created a simulated vehicle and created a bag file. And up at the top here, you can see here's the name of my here's the name of the bag file that I used. And it's good to put that on the screen, because otherwise you pull this up later and look at it and you have no idea what this was actually created from. So if you put that there, number one, I can use that when I'm running Plot Juggler. That'll tell me what file I was looking at. And the fact that I created a video here, this tells me what this was created from. So what I can do is I can go to ROS and say start up RVIZ, and then I can say go to another window and say do a ROS bag play and feed it this particular file name here. And then when I do that, it will start replaying the entire bag file. And then on RVIZ, you can see what's going on here. So well, here, how do I get that's real handy too. How do I get rid of this? Now we'll put that up here. Okay, so what we're going to do, or what you can see down in the right hand corner is my vehicle, and it's at like -3 meters, because my sidewalk is over here. My sidewalk's right about here, and this vehicle is sitting in my grass, and it's sitting at -3 meters, and it's vertically it's like 29.6 meters. And when I start this, after in fact, this will start fairly quickly. I think it will publish the path, and the path will show up over here as a straight line from about here down to about here. It'll have a loop on both ends, and this thing will just immediately, since it's on the simulator and I'm not controlling anything, as soon as I start it, you'll see it'll publish the path. It'll draw a line from the base link here up to wherever the starting point is, and then you'll see the vehicle start moving forward, and it will turn and point towards the start path, and it'll drive in a fairly straight line to get there, and it follows the path around, then it stops. So that's what we should expect here. So let's go ahead and run this. I don't know how well this is going to record. We'll have to go back. If it doesn't record well, you can go, when I post the links, you can go watch it on YouTube and see it there. So see, it's driving in a fairly straight line up to the start point, and when it gets right there, then Pure Pursuit actually kicks in, and you can see out in front here this leading marker. This is what they call the look ahead point. So it's jumping ahead to the points in the array as it moves forward, and you can see that that's pretty much staying right on the line like it's supposed to. Even when it goes around the corner, it's doing a good job of that. That's important to note, because when I move on to the next video here, you can see it just doesn't work. So that's what that just did. And let's see, it's going to autoplay again. That looks like it's going to autoplay again here. So watch when it starts up, you'll see it'll start moving forward and then turn to the left. And you'll notice the transform marker over on the it's not playing, is it? No, it's not playing. So the transform marker that'll show up over here, you'll see it'll show up on the first point of the path, and it won't move until the vehicle gets close to it. But you'll notice there's a little bit of jitter. The path or the marker will jump up and down just a little bit here as the thing's approaching it. I can't figure out why it's doing that. When we play the actual vehicle, it's just all over the place. So that's one of the current problems. So let's just play the whole thing again, just so you can watch it. Now you've seen what it's going to do. You can start watching and say, from right now where the vehicle is, you can see you expect it to start going forward and turning left, and then it'll drive straight up to the path up there. So here we go. So when I start the launch file, it says publish the path, and away it goes. And there's a little bit of oscillation right up front, but it's doing a fairly good job of driving straight. And then you can see that look ahead marker is just advancing one point at a time on the path. And then the vehicle just comes along and follows along behind. And the red mark is the odometry from Baselink. So it just leaves a path behind, so you can see where it's been going. And that also tells you what direction it's pointing. So now I'll pull up the next one, which is the actual vehicle. So if I come to here and play this one. So this one, you'll notice when it starts running here, the vehicle here again, the vehicle's sitting here, and it will start moving forward. There's the path. Now watch the transform marker right up here. Watch the stupid things that it does. So it's sitting there waiting for me to push up the joystick to make it run. So there it goes. And sees it's turning. See, that marker comes off the path, and I don't know why it's doing that. And you'll notice that the vehicle will oscillate back and forth. And then as I get close to the marker, then the marker will start advancing. And you'll notice that it still doesn't stay on the line like it's supposed to. And that's, I can't figure out what's making it do that. So that, again, that's where I'm at, trying to get that figured out. And you can see I'm driving fairly slow at this point. This should be in real time. So I can't tell if it's the vehicle is trying to drive to the marker that's off the path, or the fact that the vehicle is driving that marker off the path. So that's kind of a bizarre thing there that's going on. And it's going to stop right about here. And then just for, I thought just to get a better view of it, I created another one that is, I reran it, and this is a zoomed in version. I think it's this one. So it's just a zoomed in version of that same thing. And you'll notice again, the path will be up here. But as the vehicle starts moving forward, as the vehicle starts turning left, and when it does, you'll notice this marker will be drugged down to around here somewhere. And then when it starts turning the other direction, then the marker comes up on the other side of the line. And again, I don't know if it's the marker is telling it to the vehicle to drive there, or the fact the vehicle is driving in the wrong direction is pushing the marker off. So see, it's coming down at that point while it's turning left. And now when it starts turning right, it goes up on the other side of the line up there. And then possibly as we get closer, it calms down a little bit, but it's still not playing the game. So then the marker's starting to advance, and see it's not staying on the line either. So that, let's see how much longer is this going to go. Oh, it's going to stop right here. Okay, so that's what I was doing. And so by playing it back in RVIZ, you can see different things than just looking at it on Plot Juggler. Because in Plot Juggler, yeah, I can get plots of all this stuff, but I can't really tell what it's doing. Let's see if I just say stop sharing.
I know, don't stop sharing it. I know you're just playing a video, but what is you're visualizing that look ahead TF. Is that, how did you do that?
Well,
I'm
that's
looking
just,
at your RVIZ stuff on the left. I don't see it. I guess you just don't have that window open.
let's
You have
see.
TF there. Oh, you have look ahead there.
Right there, it says look ahead. There's a lot more of these on there, but I just have them turned off to the point where I don't have as much clutter on the screen. So basically the Pure Pursuit is publishing that transform, that look ahead transform. As far as I can tell, it doesn't get used for anything except we can use it here to do visualization. So when you run RVIZ, you just say turn on the transforms. So you come up here where it says transform and set the checkbox to turn those on. And then down here, I can select which ones I want to see and not see.
The Pure Pursuit uses that look ahead, but it's actually published in that GPS to odom Python script, isn't it?
No, that transform is the one that becomes your odom transform. So that would be down here on the vehicle. That's the one here is base link. That's the one that comes out of that GPS odom. And then Pure
Just
Pursuit.
FYI, in my GPS to odom, I'm publishing both the odom and the transform.
I am too. And that's why when this thing drives, you'll see it leaves the red odom markers behind. Here, let's just start this again while we're talking. But but down here, these transforms are coming off. The transforms are being published. As it starts driving, it'll start leaving these red odom markers behind, because over here on the left, I don't see it, but I've got the odom turned on. So right there, right, you can't really see it right there, but there is a red odom marker right there coming off of base link. And as we start moving, it starts leaving a trail of those behind, so we can tell where we've been. So the red is the odom marker, and then the transformers coming off the vehicle, or the odom transform. And then the one up here is the look ahead marker that's coming off the look ahead transform. And the path just simply showed up because when I said publish the path over here on the left, there's a thing that says path. So as soon as it publishes that, that shows up on the screen there. Oh, here, there it is right there. It says, no, that's global path. I guess all the stuff's off the bottom of the screen. You can't see it here. But anyway, as the vehicle, yeah, I can play this back and all the information that was there that was being recorded. If you're clever, you can go into RVIZ and find different ways to display that. Is there any other questions before I stop the screen sharing here?
Well, I'm just going to pull up my GPS to odom. I'm confused now because I know I have two published statements there, one for a transform. I don't know if it's the look ahead.
No, no, what you're publishing from your GPS to odom is you're publishing an odometry topic and you're publishing the odometry transform. And basically you're putting the same data into both of those.
Right.
And then by looking at what I've got here on the screen, so again, the base link transform, which is, if you go look at your frames, it'll say at the top, you got map to odom to look ahead, or not look ahead, base footprint to base link. And then, so that's how it gets the base link. So the odom to base link that you're publishing both on your odometry topic and as an odometry transform. So then when it shows up in here, the odometry transform puts up this this transform here for base link. And then the other ones, this top one here happens to be, that's representing my front axle, which actually it's where my front GPS is located. And then the bottom one down here is actually my back antenna, which is like 3.5 inches behind base link. So it just automatic. Once you put out the base link transform, then it builds everything else on top of that. So these two GPS transforms are built based off the base link transform that you have here. And then on top of that, in RVIZ, I say turn on the I say show me an odometry topic, and it says what is the topic you want, and I say it's just the one called odom, which happens to be, that's the odom to base link, is what that's built on. That you're building that. So you're building both the transform for base link here, and you're building the odometry topic. You're building both of those in your GPS to odom program. And then when you start up Pure Pursuit, it starts publishing this this one over here. Let me see. How do we start this? So as soon as it publishes the path, bang, right there. So as soon as it publishes the path, and since I say in RVIZ, I say show me the path statement, and it only gets published once. And when it does, it takes all the points. Where's my screen? Okay. So this line along here, and then this loop here, these are all points in your path that get published. And that's directly from when you published it. Whereas on the stuff you're running, you in your look ahead array, you say 0 and 1 shows you the path, and that's the result of, as it drives, it takes those points and outputs them. So some of the times when you run this, if it gets lost, you'll see it'll chop off. It might chop off part of this circle here because it's coming around, it gets lost here. And when it picks up again, it says, oh, here's a point over here. So it'll just throw out part of that stuff. So that's two different things you can see there. This is the actual path. That what I'm showing right now in green is the actual path that you publish when you go to the command line and say publish the path. That's what that is. And if you go look at your look ahead data, your 0 and 1, that's result as the thing runs, as it advances. But as the thing, say it's coming this way and stepping around the circle here. If it gets right here and gets lost for some reason, you stop creating that, and then all of a sudden it might come down here and say, oh, I found another one here. So it'll pick up and start running there again. And your vehicle might actually do that. It might come around here and get lost. Oh, I don't know where I'm at, and it'll start wandering around, and then bam, it'll see this one, and it'll lock on, and it'll start driving again. So that's another interesting thing you can do in RVIZ. You can look at that to see this is the actual path that you published. So there's no calculations going on. It's just taking the numbers out of that path array that you published and puts them right on the screen here. And there's probably other things I could have demoed here, but I just wanted to, I was trying to look at that thing where it's here. Let me let that continue. And again, as I was saying, this right there puts the look ahead transform right on the first point of the path. And as the vehicle starts up down here, it says, oh, my first point is off to the left here. So it turns like this and then tries to drive a straight line up here. And when it gets within one look ahead distance here of the transform marker, then all of a sudden Pure Pursuit actually starts up and starts controlling. So all the way between your vehicle down here and the first point on your path, it's just simply saying, oh, it's off in that direction. I need to drive in that direction to get there. And so it's actually not running through most of the code in Pure Pursuit at that point. It's just simply saying, keep driving straight until you get to this point. And then when you get right about here, the thing will say, oh, gee, I can see I'm within one look ahead distance of this marker. And then bang, the marker will jump up here. And as you move forward, then I go bang, it jumps ahead again. So you can see the marker stepping ahead. And I'll go ahead and run that so you can see that. So what to watch for here? The vehicle's sitting down here. It'll make a loop like this and point at the point, and then it'll drive a straight line up here. And then watch when it gets right about here, then the transform marker will then start moving, and the vehicle will try to get on the path and just follow along behind that marker. So I'll go ahead and run that just at least one last time here. I see that marker's jumping around a little bit. I don't know if that's noise from the GPS or what that is. Well, actually, oh, this is the one that the bad one. So yeah, it's going to do that. Now, as soon as it starts moving here, see the transform marker shouldn't move off like that. And I don't know why it's doing that. And see down here, the vehicle's also not going in a straight line towards the that first point. So that's what's got me baffled right now, is trying to figure out what that's doing. Now watch right here. Bang. Okay, the transform marker or the look ahead marker starts advancing now as you get close to it. And then we're done because we're going off the screen here and it shuts down. So that's anyway, the whole point was to show the difference that it works on the simulator and does not work on the vehicle. And I've got, the clue there that look ahead marker should stay on the line, and it's not. So that's something I can do there with that. So now I'll ask again, do you want to say anything else here while we're doing this, or
No, I'm good.
okay?
I was just looking at the Larics Pure Pursuit C code, trying to figure out where it publishes that look ahead transform.
Yeah, we should go through that someday and just say this is what it's doing, because I keep going back and forth on this. When I first started out, I looked at it and said, oh well, it's just simply trying to drive to a physical point in your path. So as your path starts advancing like this, it picks up one of those points, and I thought, well, the vehicle's trying to drive directly to one of those. But all the original code said, or the original write-up says, oh, you always have to draw a circle around your vehicle at your essentially around base link, and with the diameter of look ahead, and then you want to find out where that circle crosses your path, and then you're going to use that point to drive to. Well, that's not what this code is doing. It's actually, it says here are physical points on your path. It picks the first point and tries to drive to that. When it gets close to it, it says, okay, well, move the marker ahead again, and it tries to drive to that point. It just keeps doing that all the way around. And it's not until it comes all the way to the end, which, so anyway, the first time I looked at this stuff, I thought, well, it is driving just to a pose that's in your path array. It's just simply driving to one of those, and that's all it's doing. And then I thought, well, no, because something else was said. I thought, well, I went and looked at code. Oh no, it's got that chunk of code. It's got like 10 lines of code that says it's figure out the plot of the path, figure out the slope of the line, and figure out the diameter or something. And then it's got like 10 lines of really cryptic algebra going on there, and I had no idea what that was doing. So I convinced myself, well, that must run every time. So every time you call this and say, I am here, what do? I thought it was going through that and picking a point on the line. So instead of going to the actual point that you specify on the path, it's like interpolating between those. So it would say the point's here, but you put your circle and it says, okay, well, here's I want you to drive to this point, then drive to this point, and drive to this point, and then all of a sudden it says I'm getting close. It goes bang, it moves your path point up here, and then again it goes here and here and here. I thought it was doing that, but it turns out it's not doing that. And then just yesterday when I said, well, how does this command work? How does this back function work on the path? And you said, oh, well, that only happens once at the end. And I went and looked at the code, and sure enough, that only happens once. So the rest of the time it's saying go from the vehicle and drive to a point, a physical point that's specified in that path. So here's the first one, here's the second one, here's the third one off the screen since my screen's backwards. And it's just simply trying to drive to those all the time. So again, I look at that, I keep getting confused back and forth. So it's back to the point where I've looked at it harder now and thinking, okay, I kind of know how it's working. And then the last several weeks, I've been digging through the internet looking for stuff. And it turns out, I probably don't have it handy here, but if you go look at, everybody says, oh, this is based on that 1992 paper out of CMU that defines the whole pure pursuit concept. And you read through that, it's got some hand-drawn pictures and a lot of algebra. And the guy says, oh, this is obvious. This is obvious how this is going to work. And it didn't make a whole lot of sense to me. And I think down at the bottom, he might have said something about, so if you want to follow a path, here's the basic ways you do it. And so you go look at that Larics Pure Pursuit, and the top it says, oh, this is either said based or roughly based on that original paper from 1992. And I think the terminology here is mostly the same as in that paper, but it doesn't seem to be doing the same thing as what that original paper says to do. And then after I did some digging, I found another a website, and a guy has simply taken that original paper and cut and pasted all the hand-drawn images out of it and any little equations and any comments that he had, he pasted that together. And then he found a website from one of the first robotics teams, and they were talking about Pure Pursuit, and it has a lot more pictures and a lot more explanation. And basically he merged those two together as though this was his concept. But it does, every once in a while we'll throw in one comment, you go, oh, that's what that's doing. So that's handy to have that too, because that, somebody has taken these various things and merged them together to give you a better idea what's going on. And then another thing I was doing, and I'll post that link in the chat when I'm done here, or before I post this, or I'll post it to Slack or whatever, maybe both places. But if I post it to the chat and then post this on Slack, then it'll be there automatically anyway. So the other thing I was doing, I was digging through the internet looking for variations of this Larics Pure Pursuit, and sure enough, I found some. And I found one that's I can't remember the name of it right offhand, but this guy said that his whole point, he said he modified it so it'll do rotate in place. And I think it's something about he's got a differential drive vehicle, and he's got code in there that says, well, if you're trying to do this, instead of giving a forward velocity, it'll come to a stop and just rotate to point somewhere. And so that was there. But when I dug through his code, it turns out on that one, he also ripped out that KDL stuff. So instead of doing the KDL, he's modified at the point where he's just using like a TF2 transform stuff to do the same thing. And possibly if I'd either cut and paste that stuff into mine, I could test it, or I might just be able to take his entire package and just replace the one I have and see if that responds any differently on that. And I was thinking there's a couple more things that was different in his code, and I can't remember what they were right offhand. Number one, he changed the name on it. So instead of being called Pure Pursuit, it's now called like Dragon Pure Pursuit or something. And he did the rotate in place. He took out the KDL, but didn't mention that. But if I look at that, in fact, I think I just posted it on Slack saying, here's the difference file. And you can see where it's commented out some of the Pure Pursuit. He should commented it all out. He's still at the top. He still includes it, the header files, and he still got the little function that says the transform to base link which is done with KDL. He left that in there, but it never gets called. So he should have finished stripping that stuff out. And then I was trying to think, I found another one that if you go look at the history on that one, that's got a bunch of changes they made to that. And I didn't look at that hard enough. One of the problems is if they take the original stuff and modify it a lot, then it's going to be real hard to compare back and forth between the two. Because I found yet another one where a guy says, well, here's Pure Pursuit, and he made no reference back to the original stuff. And he went through and he was changing variable names. So instead of something like, say, L underbar, he actually renamed that as wheelbase. And so some of the key variables, he was changing the name on them. And some of the functions, a couple of the functions, he changed the name on those. I'm going to say for no apparent reason, but I guess to make it look cleaner, he went through and did that kind of stuff. So that's going to make it harder if you're trying to compare, from one to the other. So I'm at the point now where I think if I take that one where he removed the KDL stuff, and I think maybe if I just swapped it out for the one I've got, I can try running that and see if it acts any different, see if it acts any better, because there may be some assumptions there that he may have figured out something that was wrong with it and changed it to fix it. So I guess I won't know until I actually try that. Another thing, let me go back to this screen sharing again. See how quickly I can screw this up. Allow that. Okay, so if I say go here. So the other thing is I was noticing that the way this works, you've got your vehicle. So you got your vehicle down here. Its XY position of the world. Its XY position, and its heading, because that's coming in on both the odometry message, which is not used, and it's coming in on the odom to base link transform, which is being used in the code. And so your XY location, and what direction you're pointing. And as soon as you come up here to the top, again, this is in the way, but it's handy it leaves this in the way, because then I don't have to go track down the stop sharing button. So that we'll just keep that there and not get rid of it completely. And then when I start it and run the path here, so when it publishes the path, it will, in the code, it says, where is my point I'm trying to get to? So it goes out to your path array, and at index 0, that's your first point that you're looking for. So that's got an X and a Y and a heading. So see, the heading is pointing to the left, and the XY says we're right here in the world. So the code will say, do a transform between that and base link down here, and it will return back in the vehicle frame. It says the X direction to that. So looking out this direction is what's the direction to that point. So it actually comes up to about here and says that's the X direction, or the X distance to get to that path point. And then looking out the left here, coming out the green line coming out, says how far away is this to the path. So it returns those two numbers. And it also returns the transform between the heading of the vehicle here, and right now this is pointing north, so that'd be 1.57 radians, and then the path over the path point here is pointing to the left, so that would be 3.14 radians as it points to the left. So somehow I was thinking it just takes the difference of those two, and so at this point, if I do a transform between those, it'll say in the transform, it'll say the angle will be, the difference would be 3.14 minus 1.57, which would say the transform angle will be 1.57. Now I'm not sure that's what it's doing, but what I notice is no matter what I do, this marker up here, which that marker gets generated from that stuff I just said. It says, okay, now take that, and then with the reference of the vehicle, it says, here's my vehicle down here. It says apply that the X distance up to here, and apply the Y distance over to here. And what it does, so from this point, it plots those numbers and actually generates this marker out here. So this marker is not actually on top of the pose point. It's saying that's based on my calculations, this is where I think it should be. And the point is, when this thing runs, you'll notice this thing never rotates. It's always pointed exactly down the path, I think. Here, let's go ahead and run this and see what that does. That's something again, I was laying in bed this morning before I got up and thought about that. But see, that never rotates, even though the rotation that is, it should be generated from the transform between those two. And as noisy as it is, it just seems like, that should be rotating back and forth too. But see, as it moves up and down, it's turning a little bit there, I guess. Rotated a little bit counterclockwise, and there's maybe a little bit clockwise. So maybe there is something there going on. But I was going to look at that too and see if I can figure out where that rotation is coming from and figure out what should be there. So again, we're done. So that's just something else I noticed, that trying to figure out what they're doing in the code and what the implications that will be. So I guess that's kind of where I'm at right now. I'm just back to the point where if I go grab this other guy's code, and I might be able to drop it in directly, because the other problem is some of these people, when they've modified it, they put things in there that I don't really want. What was the other thing? Oh, what of them? They ripped out the Ackermann stuff, and if you go back through the history, the original stuff says, oh, somebody requested Ackermann, so it shows like 20 different changes to add that the Ackermann output into that. Now we go look at this newer one, and they just blatantly just ripped out all those pieces that created the Ackermann stuff. And since we want Ackermann, I don't really want that code. But it's comparing all these different things together. You might be able to figure out, if they've determined anything that's wrong with it, and maybe try to fix it, so that it'd be worth looking at. But it's just enough different things going on that it's enough of a mess that I haven't tried to analyze it hard enough to know if that's true or not. So I guess that's where I'm at right now.
Well, thanks for doing all that research. I was just looking at the this is the guy who took it from Larics and that you were just talking about, and I was just looking at the compute velocities function where the steer angle was calculated. I haven't well, to be clear, this was the link. That's this link.
Okay. That's the one where that's when we took the KDL stuff out of it, is what that one is right there. You're actually looking at Larics Pure Pursuit, which is what it says in your URL at the top there.
It does, doesn't it? I went to source.
So right there, before you move on, the original one said, give me a transform between map and baselink, and that was giving you your current location. Here he split those up into saying, give me the location of the robot, and give me the location of the map right there where it says robot in map equals TF buffer, and then the next one says map in robot TF buffer. So he's actually treating those. He's doing that differently there. And so various things like that may be fixing the problems that I'm seeing.
Well, this is a little bit easier to understand. I have to say.
And then right here, you see where he commented on all that KDL stuff and says, oh, just run a do transform, so that it fills in that look ahead transform directly from the map in robot. So yeah, that cleans that up a lot. And there's still places where he's copying a lot of stuff around that I'd have to go track down and figure out what he's doing. But so again, there's one he commented out the KDL thing and just put in a transform between one of those things he just created.
That looks new. So he's focused on command velocity, publishing it with the command velocity.
But he's still got the Ackermann stuff. If you go down about 5 lines, there's an Ackermann command Acker drive steering angle. Can you close that box on the right? Just go to the X in the upper right hand corner. Okay. So it's really just a matter of he did stuff in a little different order, or he's using different commands to do it. But I think overall he's still doing the same thing. And I was thinking, well, can I cut and paste this into mine? And I thought, well, I can probably just replace mine completely with this one and run it and see what it's doing.
Yeah, I mean, the whole compute velocities, his is getting rid of that KDL stuff makes it a little bit clearer what he's trying to do. Do transform.
And then down about 5 lines where it says if standard square root x squared plus y squared is less than position tolerance. Well, there I think he's doing actual geometry as opposed to, again, relying on what's falling out of the transforms or whatever. So, it just you're gonna have to look at it fairly hard to see what he's doing there, that how it works now as opposed to how it worked with the KDL and just doing a transform from here to there.
Yeah. Thanks for finding that. I think that will be useful.
And that brings up another issue. I go to GitHub and try to find other variations of this. I can't figure out how to find one that says this is the newest stuff and here's the older stuff. And but it looks like 74 different variations of this. And I don't know, you have no idea what they are, and you go look at it and my first clue is if I go look at the one that they've copied and it says everything's 6 years old, I figure, well, they haven't changed anything on it anyway. So you can find ones that are newer.
He at least says
Right there, if you go down to where it says this branch is 2 commits ahead. So go down about, right on that line right there. Click on that 2 commits. Well, this isn't what I was thinking of, but this is actually, it's saying it's going to compare this one. See, up at the top there, it says this is the lines it's comparing. It's actually comparing his master of this branch back to the master of the original Larics Pure Pursuit. So that's what all these differences are here that he's showing. And right there, you'll notice that he's still got, say, a line 21 or 23. I'm not sure which one of those is correct, but it says include KDL frames.hpp. He's including it, but it never gets used. And then he's still got that function that says create a transform to base link that's got a bunch of KDL stuff. That he left that in there, but it's not actually being used. So all that stuff could be stripped out too. So on the case where I found the one where he changed all the names in it, well, that one, since he didn't actually directly fork it from the original stuff, you can't do a compare back to that. So number one, you can't do a compare, and number two, all the names are going to be changed. So there's going to be all kinds of funny stuff in there that's not really what I was looking for.
Yeah, I know how I ended up with the Larics. So here I'm on the Howdy robotics, and then I went to this lattice navigation demo, and this points back to Larics, which is interesting. Not sure why it does that. Anyway, thanks for doing that research. Do you want me to go?
Yes.
Well, let's see. I just go to Slack. I spent more time on trying to, I mean, the end was, I mean, it's pretty low resolution here, but building this path and running this path, and you can see that it's wavy, and when I looked at the speed, it's 0.9 meters a second, and that's a little fast. I can smooth out that waviness either by slowing it down or increasing the look ahead. The look ahead on this is 2.5 meters, but it basically ran the path. This is a polygon which represents a part of my backyard. And previously I had created that path by hand, and so I had spent the time trying to figure out a way to algorithmically create that path. And so it's, as I said in the Slack, a little bit clumsy, but it doesn't take that long to decide the reference point, and the reference point is important for me because I get a little bit of GPS drift at on different days. So even though you can go to the same point, this reference point might be slightly different. But anyway, so my process at the moment is go to the same point in the yard, mark that point in the yard, get the GPS coordinates for that, then drive and get the X and Y Cartesian points, and then run this program that gives you the inner corners of that, because in the farming world this would be used for hay cutting, and hay cutting is this sort of path. It's basically a turn right path because the cutter is hanging out on the right hand side of the tractor. So anyway, it happens that the grass chute on my lawnmower is also on the right hand side, so this makes sense for that as well. So there's this Python script that creates it takes as input the vertices or the points that I represent that polygon. It would probably blow up if I put 5 points in there, so that would be an improvement to this, but at the moment it works with 4 points. So you get the first 4 points that are defined by the polygon. There's a little bit of math to calculate the 5th point, and then calculate the slope of each of those lines, and then there's a routine in here that basically you go through and create more points. That then gets stored off and becomes input into the generate plan script that we've used before, that then takes the individual points and then blows that out with a step size of whatever you program, and the step size I've got at the moment is 0.1 meters. So it ends up being, for this plot, How many? Not sure if I can read that. 1400, 1400 points when you run this waypoint generator script. So that's pretty much all I've gotten done in the last week is to run those tests. A couple other things just to point out. There's a video out on Google in the field testing folder. Just run a few seconds of that. See if you hear the sound. It finishes. Not terrible. Turn the auto mode on now with the GPS. I'm not trying to cut things down to the last inch. Can you hear the sound on that, by the way?
I can, but it's real choppy.
And then at the end of it, I just talk a little bit about the, what my physical layout is at the moment. So anyway, that's out there. The other thing that I thought was worthy of note is this is a guy who started this company called GreenZ. Jeff may remember he was actually joined a few times the old group that we had, but in this video he talks about, this must be one of his key programmers, but they talk about GPS jump and how they're trying to detect that. So I think that is going to be a ongoing challenge for us. So again, this is my Miro board. And up at the top, I've got some notes for myself on field testing. And so my process for running a mission at the moment is drive to my reference point, wait for RTK fix. For different reasons, I reset my left and right odom and IMU just to make sure they're all clear. And then I run that script to check the current lat lon and compare it to the reference, which was used when the mission was created. So I update that. It prints out a couple of statements that basically let me set the parameter for the origin lat and the origin lon. I copy those and then put those into the command line. So then I am reasonably certain that, 0.00 and all the other points on the map are the same as the last time that I ran. And then I publish the path using this program. And then capture everything on the ROS bag and put it in auto mode. So at the moment, that's my process. I think that's all I have done and is reasonable to share today. So I think I would get the same waviness that Jeff is getting. And my only solution was to, I think there were three things that I did that probably improved it. One was using my IMU that's on board and not relying on, trying to calculate the GPS heading. Increasing the look ahead to 2.5 meters. There's pluses and minuses to it, but made it less wavy. And then I think if I run it about half a meter a second to 0.75 meters a second, it's pretty smooth. As you can see, 0.9 is, it's a little wavy again. So that's where I'm at.
Another thing I was going to do, I was going to take one of your bag files and run it in RVIZ to see if your look ahead markers bouncing around like mine does. It could be something unique to what I'm doing that's making it do that, but I'm guessing yours is going to look the same way. I just haven't done that yet.
Yeah, what you did was cool. I don't think I've ever tried to um, rerun a bag file with the look ahead transform displayed. So I'll put that my most recent bag file in the Google Drive.
Is that the one where it's got the big path going all around your yard, or is it?
Mhm. Oh, well, I can rerun it. I may have one with the figure eight. I'll call it the figure eight. It's not actually a figure eight, but sort of reminds me of a figure eight. The elongated let me see if I can dig up one that one like this. I think I still have a bag file for running that. So it'll be similar. I go up the y-axis, up and down the y-axis instead of left and right on the x-axis, but it'd be similar. That's all for me.
Me too.